Hello students, welcome to the sixth session of sets. Let's capitulate what we have done in the previous session. In the previous session we have discussed about Venn diagrams as well as the union of two sets. Yeah. Now in this session we will be doing this intersection of two sets as well as the difference of sets. Clear? To understand the intersection of two sets, let's take up the example where set A is 1, 2, 3, 4, 5 and B is 1, 3, 5, 7, 9. In the previous, that the union one, that we were writing it down the common elements 1. Now in this one we will be writing the common elements only. We will not write the elements which are not common. When we are talking about the intersection, that means that points where the two sets meet. So where they are meeting, so here 1, 3, 5 are these elements which are common in both the set. So if we are writing it down, presenting in this form of set, so what we do, so the common one will be written as a 1, 3, 5 and here it will be 2 and 4 and in B it will be this 7 and 9. Isn't it? 1, 3, 5 are common. So this will be known as your A intersection B. This portion will be called as A intersection B. When we are asked to shade, so it will be only this portion will be shaded. I hope this thing is clear. When it is asked to shade, so it will be only this portion which will be shaded. So this will be A intersection. Let us consider another example. So here the example where we are having number 1, 2, 3, 4, 5, 6 and B is having 2, 4, 6. Now if you see in this, that this is the A set A and this is set B. It says B is 2, 4, 6. The 2, 4, 6 is here and A is 1, 2, 3, 4, 5, 6. So I will write 1 here, 2 is already inside, 3 here, 4 is already inside, 5 here, 6 is already inside. And for universal set, we can say the remaining, the 1, 2, 3, 4, 5, 6 are here, the 7, 8, 9 which I can take outside, isn't it? The this will become what? Universal set here, 1 to 9 it is here and 2, 4, 6 are the B. So here A intersection A intersection B will be 2, 4, 6 and if you see that A intersection B will be equal to set B. Are you getting it? It will itself is becoming B. I hope the thing is clear. Now to understand more example, let's take another example. Let's take another example. That set A is 2, 4, 6, 8 and set B is 1, 3, 5, 7. So here we are having A and B. This is 2, 4, 6, 8 and 1, 3, 5, 7. Now there is nothing common in both. When there are nothing common in both, so what it will happen? A intersection B, that will get an empty set. Nothing is common. So these two sets will be also known as the disjoint set. And now we can define this. The intersection of two sets A and B is a set of all elements which belongs to both A and B. When you are A, this will be written symbolically like this, A intersection B, and X is such that X belongs to A and X belongs to B. So when you are saying that X belongs to A and when the word and comes, so we are talking about the intersection of the two given set. I hope this thing is clear. Okay, now we take a more example when we are talking about the two sets, and I will take an example with the three sets. So what happens when we take about three sets? And here in three set, that this will be, I have taken set A as 1, 2, 3, 4, 6, 7, and B as 2, 3, 4, 5, 10, and C as 4, 5, 6, 8, 10. And this have already shown represented in the Venn diagram. This is a universal set U, and this way it is being represented. You see carefully that the elements which are common A and B, that is your 2 is common and 4 is common. These are the two elements which are common in between A and B, and it's the same thing it is being represented here. Common in B and C, that is your 4 and 5. So 4 and 5, this is common in B and C. The elements which are common in A and C, so that is your 6 and 4, which is common 6 and 4. Which I see that 6 is here, 4 is here. The 4 and 6, they are common in between A and C. When we are talking about the intersection, the A intersection B will give you 2 and 4, B intersection C, that will give you 4 and 5, and A intersection C will give you 6 and 4. If we are talking about the intersection of this with the two sets, so we are getting this. And if we are talking about the intersection of all the three sets, that is your A intersection B intersection C, so I will get as 4. If you see in all the three sets, this is 4, 4, 4 is common, as well as in Venn diagram we see here that this 4 is common. Clear? So this 4 is common. So here this will be here, and when we are representing, so we see the certain property of this of intersection, which this will clarify you that when we are talking about A intersection B or B intersection A, so this will be your commutative property. Set with the second or second with the first, that the number of elements will not change, it will remain both as 2 and 4, which we have shown here. Okay, now when we talk about A intersection B, then intersection of C, that will be equal to this. If you see this working is being done here, so we are taking A intersection B. A intersection B is what? 2 and 4, isn't it? And intersection with C. So 2 and 4, when we are talking about, so here we are having 4 in the C, which is common, so it will be taken as 4. And when we are talking about A intersection B intersection C, and again intersection of B intersection C, so in B intersection C we were having 4 and 5 common. Okay, and when we are comparing with the A, so what we are having? We are having 4 here only. The in common with this, the 4 is here, so we can say these two properties are also same. This what we have written here. If you see it carefully, so this we are having, so we are getting as 4. When we are talking about the intersection of set, any set with empty set, so we are having empty set, that will be no element in empty set, and with A, so we are having empty set. Why it will be empty set, not A, as we have done with union? So here when we are talking about the intersection, so we need to find out the element which are common. So element between the both empty set and set will be empty set. Reason ki empty set is also a subset of a set, isn't it? So here this will become the empty set. Okay. Now when we talk about the universal set and set, given set, the intersection between them, so it will be a set itself. Yeah. So if we take any universal set, say set of letters of English alphabet, and set A as set of vowels. So if we are taking intersection of between them, so we will get set of vowels as the intersection. I hope this thing is clear. Now the last property, that is your A intersection of B union C is equal to A intersection B union of A intersection C. So this property is known as a distributive property, that is of the such that the intersection distributive over union. Okay, this is there. Let's take up the example which we have used it here. So we are using the same example. So here we talk about B union C. So if we see B union C, so here we will be having 2, 3, 4, 5, 6, 8, 9, 10. You can check it here. So what we are having? 2, 3, 4, 5, 6, 8, 9, 10. So this is your C and this is your B, isn't it? So these are all the elements are written. And when we talk about A intersection B union C, so what we will get it? So here if we see in A we are having what? 1, 2, 4, 6, 7. So with this we are having, if we see that, compare it, so we are having 2, 4, 6. So 2, 4, 6 is common. Now further it says that is A intersection B union A intersection C. So first we find it out A intersection C. So A intersection C we will getting that this will be your 6, 4 and 6. When we are talking about A intersection B, we will have 2 and 4. So here we will be having A intersection C as 4 and 6. A intersection B is equal to 2, 4. Now we have here in this place that is your A intersection B union of A intersection C. So here we take it as A intersection B union of A intersection C. So if we say the union of these two, so here it will be your 2, 4 and 6, isn't it? So this satisfy here, so it is satisfying this here left hand side as well as the right hand side. So here A intersection of B union C I am getting 2, 4, 6, as well as for A intersection B union A intersection C is equal to 2, 4, 6. So this satisfies this equation. Okay. Now we come to another operation of set, that is your difference of set. Now with the help of this the word difference, we say that we are doing subtraction. Yes, we are doing subtraction of sets here, but it will be in a different manner. Now, how it is a different, let's take up example to understand this. Here we take set A as 1, 2, 3, 4, 5, 6 and the elements of set B is 2, 4, 6, 8. Now when we are talking about the difference of the two sets, that we are subtracting B from A, but what will happen? So if we are saying that we are taking up the number say 8 minus 6, so we get it 2. So we are talking here of the number, but how we will be separating, how we will subtracting the elements. So here the difference means if I say A minus B, I am getting 1, 3, 5. What does this mean? So here it says ki all the elements of set A which is present, which is not present in B, which is not present in B. So if you see carefully, so here we are having 2 common, 4 common, 6 common. So that means ki here B is having this elements 2, 4 and 6 and A is having 1, 2, 3, 4, 5, 6. So we will write all those elements which are not present in B. So if we see that 1 is not present, 3 is not present, 5 is not present. So here we write it down A minus B, that is 1, 3 and 5. Clear? When we say B minus A, so we are subtracting, so So we are removing all those elements from B which are present in A. So if we see that 2, 4, 6 is present in A, 8 is not present in A, so we write B minus A as 8. Clear? Now if we see one more thing, ki A intersection B. So if you see A intersection B, so here intersection that will be your 2, 4, 2, 4, 6. Yes, you will be having 2, 4, 6. And one thing, if you see in all three sets, that is A minus B, B minus A intersection B, there is no element is common in all three sets. Here this is obtained as a set, this is also obtained as a set, this is also obtained. But here no element is common, all three sets are disjoint sets. I hope you are getting it. Now here if we think about shading, so we can say if I doing A minus B, so it will be shaded like this. This will be your A minus B, isn't it? And with this will be represented as A minus B. And we are shading of this, the B minus A will be taking this. This will be your B minus A. Clear? So this will represent your B minus A. And if we see this, so this is your A intersection B, which is being shaded as dark. So this is your A intersection B. Now we take up the another example. Another example says that here we take a set as a vowel A, E, I, O, U, and B is A, I, K, U. So here again the common elements are what? A, I, U, and E, O, and K, which these are the elements of V and B respectively, which are not common. So here V minus B will be written E and O, and V minus B, and B minus V will be written as K. Only K is the element which is not present in V, it is only in A. So now here we can define as the difference of the sets A and B in this order is the set of elements which belongs to A but not B, and it will be written as A minus B. Now the things which we have studied, that is your operations of intersection as well as the union and the difference of sets. These three operations we have done it. Now to understand through this one question what we have done, let's take up one example. That here we take a set that is A contains 3, 6, 9, 12, 15, 18 and 21, and B takes as 4, 8, 12, 16 and 20. Now here we have to find A union B. So what is A union B? So again that we will be writing out all those elements which are present in A and B, those are common, that will be written only once. So if we say here 3, 4, 6, 8, 9, 12, 12 is 2 times, then here it is here also here. We are writing only one. 15, 16, 18, 20. Only 12 is a common which is present here. So we are writing A union B in this manner. And if you see A intersection B, 12 is common in both. So it will be written like this. Now when we say this A minus B, so here it will be your 3, 6, 9, 15, 18, 21 this way, and B minus A 4, 8, 16 and 20. So these all the question, yani this is the way that you will be representing the question or the solution. Sorry, you will be representing the solution in this manner. Now I am going to discuss the remaining part of the exercise 1.4. In the previous session, you have done the questions till 4. Question 4. Now we take up the question number 5. Here it says ki find the intersection of each pair of sets of question 1 above. So whatever it is given, So it is given as A union B, so you will find A intersection B. If it is given A union C, so you will find A intersection C. So this is all you have to find it out in question number 5. Okay. Now in question number 6 says कि if A is given 3, 5, 7, 9, 11, B is given 7, 9, 11, 13 and C as 11, 13, 15 and D is there, and you need to find out all the operations which is given. Intersection is given, union is given, and intersection of the intersection is given. So these all you have to find it down. Clear? I have explained you in the examples. I hope you can. Now in the 7th one, you need to say if A is given, 7th one, A is given, X is such that X is a natural number, and here B is given, X is an even natural number, and C is given, X is such that X is an odd number, and D is given, X is such that X is a prime number. Now here says ki find A intersection B. Now you need to use the certain knowledge of yours. Here you are not going to write down the numbers 1, 2, 3, 4, 5, 6 like this. Here you have to find out ki A intersection B will be what. Here if you see, the A is your natural number and B is your even natural number. So if we list the numbers, so it will be an infinite set. Here is also infinite set. Yeah. So both the sets are infinite set. When you are doing the intersection of B, A intersection B, so your answer will be your even natural number, because all the elements of even natural number will be present in a natural number. I hope this is clear. So only the odd natural numbers will not be written, but here A intersection will be, B will be even natural number. So similarly you have to do these questions. Okay. Now 8th one, which of the following pair sets are disjoint set? I hope you know, I have explained you in between also in this session as well as in the previous session how it will be a disjoint set. So here 1, 2, 3, 4 is the one set it is given, and X is such that X is a natural number and X is less than greater than equal to 4 and X is less than equal to 6. That means it is containing 4 and 6. So here you have to show whether it is a disjoint set or not. So if it is, how it is. So this is how you will be. Now in the 9th question, if you say A is given, these elements are given, B in these elements, and C, D. They are the 4 sets which are given, and here you have to find out the difference of sets. The difference of set A minus B, A minus C, A minus D, like this you have to find out. That means in difference, whatever the elements which are present in A will be written. It should not be present in B. If it is present in B, so you will not write all those elements. If you see that here 12 is present here, the 12 will not be written. And here 20, 16, it is not there. So here only 12 will be not written, all will be written. Clear? So this manner you will be doing it. And here the reason remaining are there. And now you see the 11th question. If R is the set of real numbers and Q is the set of rational numbers, then what is R minus Q? So R is the set of real numbers. The real numbers contains what kind of a number? I've explained you in the starting also, isn't it? The real numbers and Q is the rational numbers. So what will be the difference between the real numbers and the rational numbers? I hope you can do it, isn't it? So these all you have to